Okay, question 2. Figure 2 shows 4 items of equipment that can be used for investigations. In which of these does a force cause rotation? So, well, we can see that's the only thing that's able to rotate, unless I was to hang this on a string, but that's not the main job of a thermometer. So it is a B, a plotting compass. So gravitational force will cause the needle to rotate. Okay, next one, we're going to need our fat, moody dinosaurs, but it tells us what to do down here. So it says calculate the force. So here's our pivot, here's our distance from the pivot, and it wants the clockwise turning moment. And we know it's force times distance. And we'll just have a quick check. We're going to read the scale, and that's going to come to 5 centimeters. We're going to have a quick check. It wants the unit in meters. So we're going to need to change that 5 centimeters to 0.05 meters. So that's the main part. So we're looking at that scale there. And then we can go through. So 4 times 0.05 equals 0.2. So the trick is you've got to check your ruler. That's in centimetres, and it wants your answers in Newton meters. On to the next one. We've got a 20 centimetre ruler, has a pivot at its centre. So we can see we've got the clockwise turning moment, the anti-clockwise turning moment, and at equilibrium, we know the total anti-clockwise moment will equal the total clockwise moment. So it says use the principle of moments to show that it's balanced. So we know total, and can you see I've underlined the total, anti-clockwise equals total clockwise. I've taught you draw a line and then just do your calculations on each side. Now what's making this tricky is we've got to read from here. If you're lazy and just read 5, that's not going to be correct. So if we go through 1, 2, 3, 4, 5, well that one will work from the pivot. 1, 2.5, so that's 2.5, but students will read the 12.5. It's got to be the perpendicular distance from the pivot, so be super careful with that. So let's get rid of all those doodlings there. So we can see, well, this one isn't a problem, that is 5, and this one's 2.5. So get our fat, moody dinosaurs, and we're ready. So 3 times 5 must equal 6 times 20, 6 times 2.5. Put that in, 15 Newton centimeters, 15 Newton centimeters. Yes, we have proven it. Next one, we've got 3 gears. It says state how the speed and rotation of R compares. Well, I've told you a gear in the center, or literally idler gears in the middle, they're going to do nothing in terms of the turning ratio, because the only thing that matters is the first and the last. These will make a difference in terms of the direction though, because they alternate the directions. So let's have a quick look. So P and R have the same number of teeth. So this is the same as this. That means whatever this turns, this will do the same. And then the next part, we'll just get rid of all of this. So if that turns that way, this will turn this way, that will turn. So that go in that way, and that will then make that go the same. So it's the same and the same. Oh, sorry. Let's do it. So there we go. So we can just see it's the same and the same. So P and R have the same teeth, so they got the same speed. I've got 3 gears, so it goes the same direction. So this one's going clockwise. That's now going to go anti-clockwise. So this one will go clockwise. And that's that question done.